Section 7.5a, operations with matrices. This lesson is going to focus on addition, subtraction, and scalar multiplication only. Section 7.5b will focus on multiplication of matrices. For addition, very simple. We add the corresponding elements. However, the matrices must be of the same order in order to perform matrix addition. If they're not of the same order, you can't add them together. If they are of the same order, simply add corresponding elements. So row 1 gets added to row 1, row 1 column 2 gets added to row 1 column 2, and so on. Scalar multiplication is just multiplying a matrix by a constant. All you do with scalar multiplication is simply multiply each element by whatever that scalar is. So you basically, somewhat like the distributive property, you take that constant and you multiply every single thing inside the matrix by the scalar. Example 1, add these two matrices together. They're both 2 by 2 matrices, so we can add them together, add corresponding elements. -1 plus 1 is 0. 2 plus 3 is 5. 0 plus -1 is -1. 1 plus 2 is 3. And that is it. Here we have a 3 by 1 matrix plus a 3 by 1 matrix, so we can add those together. 1 plus -1 is 0. -3 plus 3 is 0. -2 plus 2 is 0. There's our matrix. Letter C, not possible. Not the same order. Can't add them together. Here we have a 2 by 3 plus a 2 by 3. So we can add these up. 0 plus 1 is 1. 1 plus 4 is 5. -2 plus 5 is 3. 1 plus -1 is 0. 2 plus -4 is -2. 3 plus -5 is -2. There's our final matrix. Second one, scalar multiplication here. 3 times matrix A. 3 times matrix A just means I take 3 times every single element there in matrix A. When we do that, we get 6, 6, 12, -9, 0, -3, 6, 3, 6. Letter B. Take the opposite of matrix B, or take -1. Multiply everything in there by -1. We get -2, 0, 0, -1, 4, -3, 1, -3, -2. Letter C. Take 3 times A minus B. So basically here, what I'm going to do is I'm going to take what we just found right here. That's 3 times A. This is -B. And now we would add those two matrices together. They're both 3 by 3, so we should be able to do that. Add them up. 6 plus -2 is 4. 6 plus 0 is 6. 12 plus 0 is 12. -9 plus -1 is -10. 0 plus 4 is 4. -3 plus -3 is -6. 6 plus 1 is 7. 3 plus -3 is 0. 6 plus -2 is 4. Letter D, 2 times A minus 4 times B. Well, let's first take 2 times A. 2 times A is going to give us 4, 4, 8 in row 1. Row 2 is going to give us -6, 0, -2. And row 3 is going to give us 4, 2, and 4. I'm going to change it to addition and distribute -4 now through to matrix B. We get -8, 0, 0, -4, 16, -12, 4, -12, -8. Now finally add those together. Again, both 3 by 3. We should be able to do that. Add those up. Row 1, we're going to get negative 4, 4, 8. Row 2, negative 10, 16, negative 14. And row 3, 8, negative 10, negative 4. Okay, multiple operations. Add all these up. We're going to get a 3 by 1 matrix out. Add up everything in row 1. We're going to get 2. Add up everything in row 2. We're going to get negative 1. Add up everything in row 3. We get positive 1. Letter B, follow order of operations. Do what's in parentheses first. So add these two matrices together. We get 2, negative 2, 7, 8. Multiply by the scalar now of 3. We get 6, negative 6, 21, and 24. Last one, solve for x given these two matrices and that 3x plus a equals b. Let's first take that equation. 3x plus a equals b. Let's solve for x. 3x equals b minus a. Finish solving for x. Remember, you cannot divide in matrices, so let's multiply by a third. So basically what we need to do to find what matrix x is take 1/3 times matrix B minus matrix A. So let's do that first. Let's do matrix B minus matrix A. Negative 3 minus 1 is negative 4. 4 minus a negative 2 is 6. 2 minus 0 is 2. And 1 minus 3 is negative 2. And now we need to take 1/3 times that. And that's what x is going to equal. So we end up with negative 4/3, 2, 2/3, and negative 2/3.